Okay. So we lost our recording last time. I Googled finally, and lots of people complain about it crashing when you're saving the file. And I read, did you read also? Did you, anybody? Yeah. From what I made out, all the Microsoft answers are that it's not our problem, it's third-party software problem. If their product... Well, it's some other software that, there's all kinds of third-party software. So, and there were many culprits given, but I don't understand how, when you write a program, why should your program semantics depend on somebody else? So anyway, I use this laptop only for giving lectures. So I made it minimal. I've removed everything I could imagine. But Cam Studio is here because I want to record something, and they said some kind of video software can cause problems. So anyway, we'll see. Hopefully. What we're going to discuss now, you're not going to be able to go and get Stack Overflow or other places. This is replicated objects aren't implemented in the commercial world. So we really need this lecture to be understood well and hopefully recorded. Okay. So questions before I continue? I saw that message last night about about the cars. He throws a random number somewhere to decide whether to show the cars or not. So, if you keep...
Same thing, the animation, drive doing everything, but the car messes with the timings and there's just no way to detect it.
No. So it's...
Right. Just check if the car...
But I'm just wondering, anybody else had the same problem when timing? So you're the lucky guy. I mean, if next time I want a lottery number, I'm getting it from you because you're consistently getting the random number. So it comes sporadically.
It comes, but it's like I can execute, let's say 50 or 60 commands and then the car.
Yeah, that's what I'm saying. So every time I tried, I never got it. So I never even saw this problem.
But you do just like 500 commands.
Yeah, I did 500.
Oh, you did 500.
But I've got a blazingly fast system, right?
The car goes for me, but it's not a problem.
It's not a problem?
Yeah.
Okay. I didn't see the car. But anyway, this is not my code.
It's a third-party problem.
Touche. Whenever you lecture and sermonize, it hits you back always. So, but we're explicitly building on this piece of software, whereas these guys are not explicitly building on that. But actually, I had meant to give you guys your feedback on your first assignment this weekend, but I spent most of my time on this particular piece of software, which has got lots of classes, about 50 or 60 classes, because I wanted to make it ready for your next assignment. And I had to work very hard to do that, which has to do with replicated objects. I want to make the simulation replicatable. And you can imagine that's not an easy task. Because you want to replicate some state and not other state. You want to replicate the independent state and not the dependent state, and had to figure out what the dependent state is. And I'm not sure I've got it all right. But I did run my tests and I did get what I wanted. So I've got an assignment for you, which will be very few lines of code. But it'll probably make, especially because there's no Google to help you look at templates, it's going to be challenging. You have to really think from first principles. And when things go wrong, you'll really have to understand the event flow. So please do understand this lecture well, because I'm still not 100% sure we'll get the recording. Okay? But send message to Piazza, whatever, okay. Destroy. So what did you mean by destroy function? I'll add this feature to disable animation for sure.
I want to be able to kill the command processor so that I can clean up nicely after myself and start a new session.
So you want to be able to now.
Exit command would be great.
No. But that is just a library. So when you kill yourself, that'll go. If you really want,
I just nuke it in Eclipse and just let
when you nuke it in Eclipse, it'll nuke everything. Because it's not a separate process that I'm creating. Now, if you use my tool, which is to create separate consoles, then you run into trouble. Because I told you in Eclipse you can't detect somebody's trying to kill you. If you could detect it, you can kill all the child processes. But here, there's no. But you can always reset the state to initial by either doing a move, or I don't know whether he has a set command or not. But if you really want to set the guy's position to initial position, I can put a little command there. if you want that. But this is replicating the simulation is a tricky thing. It's a tricky thing conceptually. So I think I've got it ready, and I'll release a new zip file and release a new object. I had to change a lot. I had to change sync, which I haven't dealt with for like 7 years. I had to change object editor because of a few things, and I had to change the simulation also. So that's where my weekend went. I really meant to give you guys feedback before you submit your next assignment. But if you had it all working, I mean, you don't have to worry too much. Okay, and we'll look at the discussion. Okay, and I have toyed between two alternatives for your third assignment, and that's one is that you guys do a replication yourself with RMI first, which won't be that difficult. You just have to worry about events bouncing back to yourself. And the second part using sync, which supposedly is easier. And again, it is easier as long as you understand the semantics well. But I think given this particular problem, there's enough conceptual things going on that the second part is what's more interesting. And I think the first part will be more of the same that you've done with RMI. So I really want it to be stuff that you will learn from. Okay. So I think the first part is not that necessary. Okay. So we looked at replicated objects and why we might want them. So there's 3 questions. Why do we? What are replicated objects? And since they don't exist today, except in this world of at least in my research world, we can even figure out why they may not exist. But what is the question? And I don't know why I didn't have question marks for all 3. Why and then how. Okay. So we saw why we might want them intuitively. Replicated objects exist, but not as an infrastructure. Okay. So and that's the point I want to make. And we'll see what kind of replicated objects really exist in special cases. So we saw that we can have copies of objects. Okay? That you can have an object, you can serialize it to a server, and then or directly to somebody else. Okay? And the other party can get this. So the idea is that you've got a repository here. Okay, you deposit the object here and somebody can look it up from there. So RMI registry will support that. We would just want a shared object, and if it's immutable, this is a great idea. Because you just submit it somewhere and people can look it up and they can get the object. They don't have to get a file. They don't have to get a directory. They don't have to get some very special kind of data structure. It is a Java object, okay, which can be anything. Okay? So we saw with serialization, this kind of idea works. With serialization, you can pass copies around. With RMI registry, you can have a little database of objects. Okay? And you can register not only proxies, but regular objects also. Okay? And then we saw, and so the whole idea is that if this is immutable, this works fine. If it's not immutable, we have divergent state, but local invocation methods. Okay, so whenever you invoke a method on an object, it's executed locally. So if you're not connected, it still executes. Okay. And then we saw we can pass references. Okay, so now things get more interesting and complicated. We have objects and proxies. From an object, you create a proxy by exporting the object. Okay, there's many ways to export the object. Then you go and submit a proxy to the registry, and somebody else can get the proxy. And now when they go and interact with the proxy, they actually interact with the remote object. Okay? So now if you want convergent state, something is changing, you can put it at some server. That server can go and export it to the registry. All the clients can look it up from there. And now they're all sharing one copy of it. Okay? So the invocation is remote, remote, but it's all one shared state. One shared logical state, one shared physical state. And that led us, as we saw last time, to the idea of something that combines both. Okay, so you take a replicatable object, it's in your client, you send it to some replication server. Okay, this is going to be more than just a registry. It could have a registry underneath it, but that's what it is. And somebody else can then get a copy of that object by doing a lookup. But we never created a proxy. Or at least we don't see the proxy. It's not visible to us. If it's there, it's somewhere behind. Okay. And now what's going to happen? When I invoke a method on this object, or when I change the state, I shouldn't say invoke method, but generally we change state through a method. When I change state here, we want the state here to be changed also. Okay, I mean, this is the $1 million question. How do you make this happen? Okay, there's really no really good, decent way of doing it. Even the one I show you has so many pitfalls. And it has pitfalls, and those are the pitfalls you'll have to deal with in your assignment. Okay, it'll look all very simple and nice. Okay, but your assignment is such where it'll take it to its limits. Okay.
So how is, like, with RMI, what do you get that?
You would get what? You would get, when you invoke a method on the proxy, it will go there.
Right.
I'm saying the state is local here, but it's kept consistent. So there are arrows, so you'll get local access.
So it's like something under the hood is changing the values, and so like the next time you read it, you might get a different value because it changed on another machine.
Which is what happens with RMI also, except that all calls go to one object. So everybody else has a proxy, and there's one real object.
Yeah, it doesn't match.
So remember, in the previous picture, I had two objects at the server.
Right.
Proxy and that. Now I just got one object. It's a much more symmetric situation.
Okay.
That was an asymmetric situation. That guy was the object owner. And I mean, here I started with an owner, but once it's come to everybody's an equal owner at that point. See, owner was just the first guy who created it. Yeah.
So user could be elected as a future owner of this.
Well, do we need any election here? Is it all? So first, let's just talk about this a little bit. Is this picture right? So I took this object, the owner guy created. He sent it to a repository. Okay, some name server. This guy needed that object, so he got it from that repository. Okay. And now these objects have to be kept consistent. Do these objects have to be kept consistent also?
I would imagine so. If somebody else joins the session,
They should get the most up-to-date object. Okay.
But if there's some mechanism to maintain consistency, that could be invoked when you receive the new object.
Okay, so when you receive the object, some kind of, but it'll have to come from here, no? I'm assuming that there's a central place from which you can have a pure peer-to-peer system, which is conceptually very hard. I mean, which always has algorithmic issues, and also usability-wise, people need some central place that is always alive. In today's world of firewalls, I can't be going to this guy and getting the object directly from him, typically. Okay. In fact, in today's world of firewalls, I need to also go through this guy perhaps to even change this guy. Okay. But logically, this is what's got to happen. And I probably want this thing to be up to date all the time. Okay. So now again, we're seeing how different it is from RMI registry. RMI registry doesn't go and invoke your methods. This guy's got to invoke your method. This guy can crash now if your methods. So this is getting very dangerous stuff. I mean, you're invoking methods on the server. People talk about customizing the operating system by adding your own code. And when you add your own code, you can just compromise the operating system because it can just go into a loop. And if the OS is executing that in system, so there's all kinds of dangerous things that can happen when you start code being executed in some server. Okay, and so things we are treading. It is somewhat dangerous. Okay, and ideally we want the server not to be, server per application, so that your application goes and not server for the whole world. Okay, so you want many servers. For each application, you would have a server. If you're playing a game, you'll have. So games, actually, I don't have that example, but games are examples of replicated systems. Okay, you want fast response, and yet you want your world to be consistent with that guy's world. And so that's like a perfect example of a replicated system. Okay? But you guys get what's supposed to happen? How is going to be a very tricky issue. So basically, it's logically this is what's going to happen. These copies have to be kept consistent somehow. Okay? So before we go into the how, because we're going to make compromises, let's go and see why we want this, because then we can understand our compromises relative to what the user needs are. Okay? So basically the idea is the shared state, local invocation to get access to the state, but even though the state is shared. Okay? And we'll call these guys as an association. This object, and this object together. Somebody said session. We'll just call it an association. Session has a very temporal semantics that session is alive now and is gone later. We'll just call it an association. Okay? That these are corresponding objects in an association. Okay, so this is these are replicas, or and together all the replicas are an association. And we'll see these are not necessarily replicas; they may be versions. Okay, so they may diverge because we wanted them to. So that's why they're really versions, and we'll just associates, and we'll call them together an association. Okay, but for now, think of them all being exactly identical. Okay. Okay. So, I told you games are examples of replicated objects. Okay, that basically the world that you're interacting with. I don't know. I don't play games.
Online gaming, they're
Are there any games that are purely centralized, that everything goes to a central server?
yes. Yeah, but MMORPGs are all.
And in fact, a lot
No. There is a server. I understand that.
Yes.
But does every keystroke go to the server?
Yeah, well, in shooters, usually you send everything to the server, and then it redistributes the actions back to the client so that everyone's games are in millisecond lockstep with each other.
Yeah,
Okay.
It actually does periodic.
Okay, no. But supposing your user interface is one of displaying what, a tank? I don't know what games have. Okay. Does the user interface go to the server to get the tank object?
No.
No, it's
No,
sort of
it
locally.
only sends data. Like,
Yeah,
if
like
you have
it's
to have the
position
map,
oriented.
It only sends user like commands. It only sends-
Yeah. So basically, the whole state is local, right?
Yes.
The UI is displaying. As far as the UI is concerned, the UI is just creating the widgets to display it, right? The UI is working from some state. That state is local. And whenever you go and change the state in one place, through a server, it gets changed in other places. So it's a replicative system. In a distributed system, the whole state would be kept in one machine on the server, and every UI action will go and make a remote method invocation to go and display the state. That would be a distributed system.
But aren't devices supposed to be very, very fast? That would be like that.
That's why we want.
That does something like that. What, Jackknife is a Falcon game thing that renders games on the server, and then
In turn-based games, I think it would be okay.
Yeah. But okay. So you're buying my argument that replication is good. Okay. So first thing is that is replicated. It's not, it's not like there's one particular guy, one particular person who's got the shared state, and everybody else is making remote method calls to it. The fact is the state is replicated, and it's kept consistent. And it so happens that the consistency is done through a server, which is what we'll see in sync also. Because you have to make the sync object, make the server object consistent anyway, and let it keep track of everybody else, and let it worry about the firewall issues, and it can distribute the actions to others. Okay. So games are an example of replicated systems. What are some more mundane examples that you might know of replicated systems?
Like banking,
Sorry,
like banking.
banks. So banks are replicated in what sense? Isn't all your information? Yeah. So tell me, they are, but tell me how exactly.
also
My money doesn't live in the branch that I go visit.
I
that's what I was going
see
for, so like-
changes online because if I make a deposit right now, I'll probably see the change online in 5 seconds.
Fine. So what's going to happen? You've got a little web browser. It goes to a central server, which is maintaining your state. Okay. It goes and fetches it back, displays it to you, which is the browser's kind of replication, just a UI state. And the state. So the state is kept in one place, right? That's like a centralized system. Okay. When your browser goes away, the state goes away. It's not as if there's somebody always kind of trying to keep that consistent. But no, hang on. Is that what's going to happen really? That all of us going to go to one particular? Probably in the banking we will. Okay. But what's another alternative? Okay, so what about airline reservation systems? What's different with airline reservation systems and banking systems?
multiple airlines.
Yeah, think only one airline for now. That's okay. But
multiple airports. So
it's all, we can keep all one central database of all the airlines, but
You got one plane that everybody's trying to get on as opposed to a bunch of different accounts.
so that will cause some kind of bottleneck if we have one server.
Yes.
That's the trouble with central servers, right? They can be bottlenecks. And you might want to, I mean, what happens to your Gmail? Is there one Gmail server that we all go to? Is there one news server that everybody gets news from? And so you have replicated servers. Not only are things in the game case at the client end, at the local, your computer had a replica of the state. Now, and there was a server. Now imagine there being replicated servers themselves. And what's the difference between bank and airlines? Bank and airlines, that's server. Airlines is also server. Somehow banks are special. Be more careful. I mean, what's the danger in replicated systems?
Security.
Security.
Someone can fake their local state.
And
They get out of sync.
they could get out of sync. If you're really interested in them in being in sync, I mean, it's very painful. If your airline system is not in sync, what happens?
You overbook an
Someone's
airline possibly.
inconvenience.
Sorry?
You might overbook a plane.
And so what
It's a
happens?
Big deal, they do that anyway. They give you a refund.
They just say, okay, take a free ticket to anywhere in the world, with these constraints. They know that you won't get them.
good for us. We should have replicators.
And banking system too, right? You get all your. No, I mean, even when you go to banks today, if your transaction is less than a certain number of dollars, they don't bother about consistency. They say, sure, we'll take the loss of $500.
Well, it's synchronized periodically.
Yeah.
At the end of the day.
End of the day, and they say we don't have to worry about you not having enough money. Okay, so even they're saying that the cost of synchronization is very high. Okay, so we've got these games with these local things. We've got these servers. All the servers could be replicated. What other examples of replication you might have seen or you actually use all the time?
Google Docs.
Google Docs. Are they replicated?
One that said this. I'm not sure how.
So you mean the server, the document is kept in multiple places?
Well, when people are sharing a document,
So that's a good.
pull the local server document.
Do
and
they,
update their
though?
state.
Do they though? That's the right
I would
question.
imagine the browser would.
The browser's just got the local state.
Necessarily have to, though.
That's true, I guess.
So that is what they
Text and images, you could
You
probably just send that.
They could be rendering it from the server.
You say something? Share with others, so that's one way to do it. Imagine you're doing a PowerPoint show in Google Docs. Right? Do you want the state of all the slides to be the server, or do you want it locally as you're going through the presentation? The server, local. To the server because? So, no, fine. You can access, just imagine PowerPoint being done to multiple sites. I'm in Australia, you're in USA, somebody else is in China. Do we want the slides and the current position?
Oh, no.
But that's what Google Docs will give you right now. In Google Docs, the presentation will be at the server. All the slides are there, and it'll go and send each slide to you as you need it. I haven't seen it, but I know the architecture is probably that way because that's what they did everything else. Actually, I shouldn't say they. The way Google Docs evolved was that they did some things on their own. They did a spreadsheet on their own. Then they acquired a company called, anybody know? That did the Word stuff? Writely. So they acquired a company called Writely, and I don't know what they've done with Writely since then. Right?
I remember that.
Okay. But they've got a centralized architecture, and your web browser just keeps getting the images when it wants. But what's an alternative solution?
You download the whole thing and then submit changes.
And just going, what are the changes? I'm on slide number 5, 6. This much amount of data.
But slides get broken because you know that they're not going to change how they
Yeah, the idea is the assumption,
That would be like a.
Oh, we're talking about giving a presentation, not.
not creating a
Okay,
presentation.
I thought we were still editing.
No.
Okay.
You can in Google Docs. You can apparently. I've never tried it. but you can do a presentation. Okay? But all the tools that today are commercially available for presentations are replicated systems.
Even Prezi.
Sorry? God, I shouldn't say all. Never say all. All the ones I know about. I don't even know about the system. But live meeting, WebEx, I'm sure. And if they're designed, if there's any intelligence there, they will.
Prezi is the one which was so bad.
Oh, that's motion sickness is a terrible trait.
So,
It's getting popular. Basically,
It's getting very popular.
it's like a Google Docs version of the.
But it runs on
PowerPoint.
Flash, so I
Yeah.
don't think the system is replicated. I think
Okay.
it's purely
It runs on Flash and has horrible animations between them that like
It
zooms
does,
out,
and you can
does some
actually
flipping around.
You can
stuff.
actually use it very constructively. But yeah, people tend to.
so what is this application again?
Prezi.
Prezi.
Prezi. It's very. It's quite good.
And what does it do? It.
It's just a new way of making presentations.
Okay.
Using
Right.
embedding and stuff and-
Okay.
So the whole transition concept of Prezi is about zooming in and out in a big picture.
Okay. 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 So your contacts replicated. If your mobile phone is disconnected, you want, your podcasts. Okay. So this not mobile computing and replicated systems go together well. Okay. Any other examples of replicated on desktop that you might use?
Dropbox is replicated.
Okay. So Google, Sky, Amazon. I didn't mention Dropbox here. I'm surprised. Okay. So Sync, the whole motivation of Sync, and Sync was invented by a student of mine in around 94 or so, was a Dropbox-like system, was an example of that. Basically, you want to do every one of these things using a system like that. And it's very interesting that I'm right now using Dropbox to sync across my multiple machines. So I've got a little thing, Dropbox thing called sync, and so, but anyway, that was. So servers, airline commerce, transaction system. This is where the database guys get into. They will give you guaranteed transactions with asset properties, expensive, and very slow.
Source code repositories.
Source code repositories, very good. Yeah, they are replicated, and it's not. But you have to explicitly replicate and check in and check out, right? So, yeah, but it is replicated, and they worry about conflicts. Exactly, they worry about all the things. That's why I said that these are not replicas necessarily; they may be versions. Okay, and okay, so we've got these examples. What are some of the reasons why we want replication? So, why did we want replication in the case of the game?
Reduce bandwidth.
Performance. Why did we want replication in the case of Dropbox?
So you don't have to download a file every single time you want to request.
Performance.
And redundancy. In a lot of cases, people use Dropbox for the sake of redundancy.
Yeah, today a student of mine came and said, "Hey, I lost my whole disk." This happens a lot to my students, And I mean, it really does, I think.
Most often around due dates.
Yes, that's when you sort of know. But it does seem to honestly happen. And I'm just wondering why people, don't just have, and I said, "Do you use Dropbox?" I've never heard of Dropbox. So I was surprised, an undergrad student, but I'm a big, I've got a lot of free storage from Dropbox because I've sold this. I get so many. Okay, so we want performance. And in the case of contacts, why did we go and replicate our contacts on the mobile computer?
Well, in the event that you can't connect to the data, you should still be able to make a phone call.
So disconnection, which is an extreme case of performance. Otherwise, I have to really wait till the next time I have my enough bandwidth to go. Supposing I really want to have a low amount of data limit, I have to wait for next month's cycle to go and get my data, right? So that's okay. And why did we replicate in the case of the servers again? Google server, Gmail server again?
For sure.
So avoid bottlenecks. So
No bottleneck. Okay, performance. And why did we replicate your source code?
Like,
well, that one so you can modify.
yeah,
both
it's for
the
like
way-
logistical purposes because nobody wants to see you checking in things like misspelled variable.
So you want transactions.
Yeah.
You want things to be, you don't want every little, you want the stuff to be saved, so you don't, and yet you don't want incremental sharing.
Yeah, it's like smooth over the transaction.
Okay, so let's see whether I've got all the reasons. Performance.
Small question. There's certain databases which are distributed, as in some fields may rely on one system and other fields rely on one system. Would that be replication, or it's not data replication, but all of the
If the fields can overlap, then it's replication.
yeah, sometimes the fields overlap. So that would be something like partial replication.
Yeah. And partial replication is what again is and that's we'll see that sync has been designed to
Might be like primary key versus X set of attributes on one.
Yeah, so this one thing is just distribution. Okay? Where some parts of my objects are here, some part of my objects are there. In fact, one of the first languages to come up with this idea of just having data that's distributed among many sites was a language called Argus, invented by, if you guys remember, but you probably don't, by a famous computer scientist who was mentioned in this class before, who won the Turing Award, Liskov. Okay? So she did distributed objects of that kind where you could have, she didn't do replicated objects. Okay? But she did do distributed objects where one part of the object could be here, another part of the object could be somewhere else. And with RMI, you can have that. That's essentially what you have with RMI. Okay? That you can have links, some of them with proxies and some of them are going to your local objects.
But in RMI, the data doesn't seem at all. The object and all its fields will reside on one machine.
Yeah.
Only a stub which knows.
So it's not replicated, it's distributed. When you talk of some fields being on one computer and some fields being on another computer, that's what you get with RMI, as long as there's no overlap.
So imagine that you're giving out, like you have an object that's made of other objects, and those objects are liquid. So your amount, like the one super object, has its various fields distributed to these other remote objects. Like,
But I thought in RMI only like distributes.
well, that's what I'm saying. So like you have one object that has has different data objects, and it has stubs to data objects that are somewhere else.
Yeah, basically one object, as long as an object resides only on one machine at one time, okay, which is what you're talking about, as there's no overlapping, then you can build a super object that has links to this computer, some links local, and that object is distributed. Just imagine your table having part of the table being residing in one machine, another part residing in another machine, and those are stubs then,
So the stubs actually.
are the links.
Stubs.
Okay. So local access and Dropbox application sharing. Application sharing I was talking about, I guess I didn't spend too much time on application sharing. Application sharing is your games kind of situation. Your PowerPoint, your games, you could do your Word editing that way also. Okay. And just to show you how hard this problem is, at least from my point of view. So before Google Docs came around, I went to Microsoft for a year and I said, guys, we've got to do collaborative Word, collaborative spreadsheets, and collaborative PowerPoint. And they said, great, we'll all do it. And I came up with a team from like 5 different parts of Microsoft that never talked to each other. And we tried to go along this path. And then we saw that you just couldn't deal with Word code. Okay, and they said, are you kidding us? We're not going to change that stuff. Okay, so when I spent the whole weekend trying to deal with Bo's simulation to make it replicatable, I saw on a small scale the problem that would have occurred there. So they just gave up and said, we can't do that. So I couldn't achieve much that time. But Google Docs then said, okay, we'll just start the world from scratch. And so their Word and their PowerPoint are not as fleshed out as Microsoft's, but they're collaborative. And they're centralized, they're not replicated. But I wouldn't mind it centralized in Microsoft's case also. So it just shows you how hard it is to take legacy code and make it distributed or make it, we saw even with RMI that you can't just take local code and make it very easily distributed. You've got to go change the code, implement RMI, remote interfaces and so forth. So it's a difficult problem. Okay. Fault tolerance, we didn't even mention this. So what happens when one of the servers is gone? Okay, you need some other server. Redundancy, we talked of redundancy, and that's kind of what is happening. Okay, that you can withstand failure and disconnection both. And it's a special case of performance, that can you respond before next failure recovery or next connection. Partial sharing. Okay, so when I go and share in Dropbox, I take only my Dropbox directory is shared, not my whole file system. And even within Dropbox, only some direct folders are shared with somebody else, others aren't. Okay? And then long duration transactions. I don't want to see your every edit, perhaps. By the way, when you guys say that we don't want every edit to be seen, today's software engineering research is saying, yes, we do. It's people don't want to share that change. Okay? They don't want their repository to change immediately. But they want to see what you're doing, because then they're more aware of what you're doing. And there are big problems today because of isolation among programmers. So right now there is continuous coordination is the buzzword. Okay? And I have contributed to this buzzword by saying that you should have continuous conflict detection, for instance. That whenever you do something that can potentially conflict with me, I should get to know at that point and not when you check in. Because you know what happens. Have you guys ever done collaborative software engineering project? And supposing you've done your task. So supposing you and I are coding together, are you keen on checking in before me, or you don't mind checking in after me? Before, why? Who will have to fix the conflicts?
The other guy, you check in first.
So people are in a hurry to check in. Okay? Because the other guy will go and fix the conflicts, if they at all find the conflicts. Okay? So, can make only part of the file system available for sharing, and you can have long duration transaction until data is committed, it's not shared with the world. So you can make changes private, can avoid network costs also. Okay, so I can go and make 10 changes to my contacts here, go home when I have a wireless connection, it can go sync at that point. I don't have to sync it every little instant. Okay. So our shared state requirements imply now it's becoming more dangerous. I mean, more tricky. We want the synchronization. We don't know how the synchronization is going to happen actually. Plus, we want user programmer control of which parts of the object is shared, whatever a part means. We don't even know what a part of an object really means, and when they're shared. Because if you're going to have transactions, you want to go and share them, not now perhaps, but at a later time. Okay? So my requirements on the system have become much stronger. Okay? And like RMI, I might want to say that, look, I don't want any special language support. Okay? Maybe this is a false requirement. But it's nice to. If you can do it without language support, it's nice. And it'll be nice if we can do it without any compiler support, and we can just create some proxies or something else later to have this all happen. Okay? So these are our requirements. And let's go and see how we can meet them. Okay? And why don't you guys think in the background, and I'll give you some. Okay, so let's go and answer two questions. The one question is easy, and the other question is hard. So how would you create the replicas? So there are two issues. First, I have to go and place the replicas on all of the computers, and the second, I have to keep them consistent. So how might I just create the initial replicas? How might I just distribute the replicas?
We could just serialize it to like the RMI server or the RMI registry process that we did before, except in this time. Instead of sending the stub, send a login.
Just use RMI and serialize. Okay, that's exactly what sync does, and that's what we'll do. Okay, so that's the easy part. The hard part, so I think the next slide says. Okay, so my replicatable objects all become serializable objects now. Again, by the way, one of the things I had to do when I looked at Bo's code was, just I had to serialize things and make things transient and non-transient also. Okay. By the way, the student Bo was really an economics major, doing just 401 for fun. And you can see what a fancy project he created. So, okay. So that's the easy part. Now the $1 million question. How do you keep them consistent? Okay. Here's what you could do. We are trying to keep the state of the objects consistent, right? The state is captured by variables. So every time I go and change a variable at one site, I go and change the variables at the other site also. So I have essentially got replicated memory.
Isn't that dangerous though? Hit it with complex. Like, if
Yeah.
someone,
Go ahead. I was gonna say this is exactly like with Git. At some point, like no matter how good your merge algorithm is, no matter what, like you're gonna have a conflict, and somebody's gonna have to sit down and make a semantic decision that isn't that you just can't come to unless you have a semantic knowledge of the content itself.
Fair enough. Whenever you have replicated objects, okay, you will end up with conflicts. That's a given. You're living with that. If you allow multiple people to change, you don't have to. You can have locks. Okay? So you really don't have, when you have transactions, you can go and say, okay, this transaction will be serialized. Okay? And whenever you have two users involved, whether it's replicated or not replicated, you can have situations where the two users disagree on what the next value should be. And in distributed systems, the latest one wins. That's just by semantics. Okay? Whether that makes sense or not. In replicated systems, also you could go and have those semantics if you really want that. Okay? And in distributed systems, it's very quick. So the state can't diverge too much. Here, because I'm allowing long duration transactions, the state can diverge for a long time. So you might say, oh, all my changes got replaced by the latest changes. I don't want that, and that's what you don't want to get. Okay? And that's when you get into some conflict management things. And in fact, Sync was designed to be the most general and high-level and flexible system for object merging. That is what it was meant for. That we could go and do the merge, all the merge policy that ever existed, that anybody had written ever, we could go and do using a declarative mechanism rather than a procedural mechanism, which I will not get into in this class. Okay, so, and in reality, by the way, are conflicts really an issue? In reality, I know in theory, all kind of bad things can happen. In reality,
I mean, not as much as people thought. That's why, like, source management systems originally started out as locking, and then they realized, like, well, in reality, we're not going to hit so many merges.
In reality,
that when you do hit them, it's a very manual process.
In reality, the danger is that people won't do work and do their task. The danger of them doing somebody else's task is even less, And as long as you have divided the tasks well. So, when I came here from Purdue, I mentioned, so I had a system called Suite at that time. And there was a guy working on access control in Suite. And there was John Munson working on synchronization. Sync was the system that came later afterwards, on merging in Suite. And they're working independently. And Hong Hai, who would do the access control thing, he finished his work. And I just took the RCS merge or whatever merge, and I took John's code, and I did it diff-based merging, and I just prayed. And, I ran all my tests, and they worked. This was magic. Pure magic. That's because one guy was doing access control, the other guy was doing merging, and they didn't interfere. Okay? So in reality, things are much better than in the worst case. But we won't get into that stuff, that gets into more, I can talk a lot on merge semantics. Okay, but we'll just assume there is some reasonable merge semantics. Okay? The question now is, what are we merging? How are we decomposing the object into its parts? Okay? And when are we merging? And I'm saying, assuming no conflicts or conflicts won't happen, let's just ignore that issue. What do you think of this kind of mechanism? But before I do that, you had some questions.
Yeah, just mind getting into it, but wouldn't one copy need to be authoritative in some way? Like if you're merging, an address book, you could say that, the one on your phone is the authoritative copy, or the one on your desktop computer is the authoritative copy.
So, let me tell you guys the story here, the thing here. That forget what's the right merging. Just to make sure that all of these copies are kept consistent is an extremely hard problem. Just getting it right. That just making all of them are consistent. And there's a lot of papers that I, as an editor and reviewer, have accepted that have been found to have flaws later, where they've not assumed a central guide. Okay? And Google Docs' merge algorithm is actually done from a research paper that was published in WIST, which is a conference on user interface software and technology. And it uses a certain algorithm that assumes a server. So you have to merge through a server rather than merge directly with each other. And there's a guy who used to live in Australia who always was against these semantics. And he said, no, I don't want, if I'm in Australia, to go to California to merge my data. Okay? He just says speed of light is so slow. is so low that I'm going to have a very slow response. That's why I mentioned the word Australia, because he was always very far away from the world, and he has tried many algorithms to do direct peer-to-peer synchronization. And he came to Microsoft, and I was there at that time, and he said, "Oh, I've got Word that works, collaborative Word." And these office guys said, "Really?" They said, "Can you just give us the laptop for 1 second?" And in about 4 seconds, they had broken a system. And not because of the merge algorithm, it was basically because they knew certain events could not be captured in Word. They said, "We cannot make undo work correctly. How can you make replication work correctly when we don't even get all the undo events to undo?" So, but anyway, so yes, getting the semantics right. But right now, we'll just assume that there is a primary copy through which things are synchronized. Okay, so that's again at the logical level. Now at the implementation level. Assuming there's no conflicts, assuming we have algorithms for doing all of this stuff. Every time I change a variable, the variable changes on the other machine?
It doesn't align with our wanting to do things transactionally. So what if we change the variable, decide, we don't like that, and then change it back before we submit?
So it goes to another message goes, okay, because every step. And
You really only merge
we don't know when we need merge, but at least we don't want merge immediately.
Right.
Right? And maybe we need merge only when we do read. Okay, maybe we can pull the data. So there has been research on distributed shared memory. Okay, every time you change a variable here, some copy gets changed. It was a very old CMU thesis. Okay, it gets changed at the center, and people have done this kind of stuff. But replicated memory, nobody's done. And then also, we don't want to change the compiler and change the language, right? This means that every assignment statement has to be sending a message. Slow, not what we want, and changes the compiler. Okay. So this would really mean that So here's an object, just an example. It's got these variables, a float variable, an int variable, and the basic idea is that whenever I go and change this int variable unit cost, it gets changed everywhere. Okay, that's what the semantics would be. We replicated memory. And that would mean that my assignment statements have to be compiled differently, and they're very costly. Okay, and this guy who did distributed memory, he did change the compiler. Okay, so it's doable, but it's probably not what we want. Okay. So things are getting hard. We've got variables, we've got methods. So let's try with methods. So we're invoking the assignment remotely, and compiler support, costly, no control of what and when. Okay, no transaction support. So we've got variables, we've got methods. Should we broadcast all the methods? Every time I invoke a method here, it can change a bunch of variables. We've got some kind of transaction. And that method is called at other places.
It's like one of those problems. It's like you're almost taught to avoid it because your objects you have to have some kind of like transaction semantics somewhere.
Well, so what if we say that the method execution is the transaction? Like you store it into a problem. What if I decide I didn't want to call that method?
And then like what about your class variables?
Yeah, so the same method is invoked in other places. So every time I invoke a method on one object, so what we do is we build a proxy object. Okay? And that we can imagine having a proxy at each end. So proxy object, so we're always going through the proxy. The proxy invokes locally and remotely. I mean, it seems like a very clean it's a clean, very straightforward extension of what we did with remote method calls. Proxy object, and proxy was going to a remote place, now it goes to everywhere.
Doesn't scale.
Doesn't scale.
So the more other people who are involved in your system, the slower my computer runs.
Okay, so that's one thing. That the method will not return till it has executed everywhere else.
Well, so how about when we're trying to do an RMI-like thing where whenever you call a method on your local copy of the object, it...
Hang on. In RMI, there is no local copy of the object.
Well,
There's a proxy.
Okay, so... But I'm thinking about making sort of like a hybrid of it.
Okay, which is what I'm talking about here. Yeah.
So like whenever you call a method, it executes the method on the object stored at the server. And then whenever you, like what he was saying before, whenever you try and read any of the values, it pulls the value from the server and copies it over to your local.
Okay, so suddenly you're talking of read and write. My method in RMI, is there a notion of read and write? We didn't, right? Here, I just said broadcast all methods. That's all my method invocation system knows. It's a method. What's a read method, a write method? Now, that is the key actually to solving this problem. But if we don't know what a read or write method is, that means that if I do a get method here, it gets sent everywhere. And wait a minute, what value do I return back? My get returns an int, and am I supposed to return an array of ints? Okay. So these semantics are failing, at least the way I've described them. If you're going to broadcast all methods without trying to filter the methods in any way, you run into trouble. You don't get the, what did local access really mean? I said local access, I left it all undefined. Local access means reading the values. Okay? It also means that my write should ideally go and return immediately without having to wait for everybody to execute. Okay? I should be able to do that. So this is what would mean that you broadcast all the methods, and we can build a system like this. And now this would mean that, when I go and invoke set number of attendees here, it gets invoked at all the places, and we have to make sure that you don't get it invoked right back to me. Okay? And did you guys have to make sure of this in your second assignment? If you use process command, you don't have to worry about it, right? Because that doesn't fire any events. If you use set input string at all the places, then you have to worry about the event bouncing back to you. And that's a very tough problem. It's a tricky problem, and unless you have, some extra facilities to detect who sent it. So we have to make sure that we don't, we have to somehow have a transaction ID with it and say, okay, this particular method invocation was this ID, and then if we get it back, we don't execute it. So that's what we would do. But then, so we can create a proxy that traps method calls and broadcasts them. All methods incur overhead, even the read methods. And the read methods, we don't even know what the semantics are because they're return values. And what does it mean to return a value when it's invoked at all places? Okay, so we're getting into conceptual issues. Okay, now based on all this framework that I've shown you, what's the solution then? And based on this example also perhaps? We're not going to give up. We want to create replicated objects.
A cache of some sort? Like your proxy can act as like kind of cache and state manager, so if you call like set A, set B, set C, I don't know, it could like...
Okay, so set A, set B, set C, so you're trying to say that there are special kinds of methods called sets? Yeah. Oh, don't give up.
Yeah, I'm just trying to think, like, if you're broadcasting every method, I don't know where I'm going. You got the argument, you have to send the argument over, you have to do it on all the objects.
Yeah, sure. We can do that. We are doing that with remote method invocation. Right. We know how to do that stuff. We know it's doable. We don't know how to do it right now quite. You'll do it in your next assignment, one of your future assignments. We'll do the implementation also. But we can send that data.
It just doesn't seem like there's a way to do that in a way that doesn't have a huge performance overhead.
No, why? So the general theory behind replicated objects is that your writes become slower. Okay? If they have to wait for the state to be consistent at all places. There's two ways to go around. One is that you just do the write here locally and then send the message afterwards in a separate thread to the rest of the world. Okay? So your writes don't become slow. But then, if you send that in a separate thread, then your consistency becomes tougher. Okay? So assuming you're going to just make an atomic write, then your writes become slow. And those writes become slow only in these banking systems. All the other systems say, hell with consistency. Weak consistency. Okay? News is an example of that we'll do, this is often typically called best effort also. You know, we'll do something. I don't know what best effort really means, but basically we'll do something. But your reads become fast because you're doing local state stuff. So as long as there are fewer writes per read, you win in replicated systems. If there are lots of writes and few reads, supposing you're appending to a status log, and you're only appending, you're saying, look, here's my report from here, and here's my report from there. You just might as well keep it centralized, and you're never reading it, you're only writing it. It's like some journals people talk about, write-only journals. And so you just, you would take distribution. Okay? So don't worry about performance. Let's just get this right. That we want something that doesn't require compiler support, language support, that gives us performance benefits when the number of reads is high compared to the number of writes. Design a system now, and I've led you all the way to it, more or less. And you were there with it. You're kind of giving up too quickly. So I can't broadcast all methods. So what method should I be broadcasting?
Or you're right.
And how do I know a method is the right method?
Whether it returns void.
So if it's a void, it's perhaps
I mean,
If you specify this right method, that's what I meant.
okay, but then I need some kind of But
Syntax.
But is there any-
as a mutator.
If there's some form,
If it's a mutator, if there's something on the left hand side.
no, how is the mutator? Am I following some conventions here?
Oh yeah, if you follow the get set conventions,
And is that such a bad thing to do?
it seems like it should get you into trouble. But,
No, but
yeah.
following conventions is good.
Yeah.
the method name contains the word set, it's the right method.
It's really, I think I might have the exact semantics, but it's really set. I mean, there's a formal definition.
Oh,
You
yeah,
guys,
like the
do you
Java
know?
Bean definition
So
is there.
why is it called the Java Beans definition, by the way?
That's a great question, I never knew.
I don't know, but it was to help with tooling. I think originally
There was-
the whole idea was a no argument constructor with getters and setters was so that you could take the object and a tooling system can look at it and create the object and let you say like, oh, the color of the here's a window. The color is blue, set color. The title is this, without having to do all kind of special stuff on it.
Perfect. There was a tool called the Beanbox. Okay? And they built this Beanbox to create UIs and connect UIs together. And they looked at the UI properties. And the tool had to go and figure out what the attributes were that you want to customize in the UI. It had to find these attributes. And it just assumed that you have an attribute. I don't know whether I have a slide for this or not next. But you have an attribute or property P of type T if you have the what signature for the getter?
Return type T, get property name,
Get P,
arguments.
get P, yeah, right. And you have a setter with the signature, void set P, one argument,
T,
T.
B1 or whatever.
That's it. And they build a bean tool based on that. And why can't we build a replication tool based on that? It's good. If a tool can understand, if a stupid computer program can understand, a smart human being can understand what you're doing. Yeah? And people use this convention. So if we can figure out some conventions, and what those conventions are is immaterial. But as long as we can figure out some conventions to describe what is a read method, what's a write method, then we've got a solution. Almost have a solution. So whenever the write method is invoked here, we'll invoke the write method there also. But we don't want to go and, so we can have a proxy to do that. But how can we give a program some control over when that change really occurs? Or can we again use something that already exists in the world today to not have a proxy, but to have an alternative solution? So,
Some kind of like command buffer.
no, so how does the system know that set has been called? One is that we go through a system proxy to do it. Is there any other way?
Key variable changes.
So how does
You can get
this?
like a change listener or something for all of your setters, so that whenever a setter gets called, it flags the listener.
It goes and fires an event.
And then I guess then you have a decision to make whether you want to make it sort of a vetoable thing where you don't actually set the value until everything's in sync, or if you're okay to get in sync and just assume the rest of the
Absolutely. You can have a vetoable thing that will go and be used for concurrency control or access control. And we just, and is making an object an observable, which is what we're doing. We're making the object an observable. That means it fires events when its write state changes. Okay? And is that a bad thing to do on its own right? It's a great tool. You can extend systems so many ways. If Microsoft Word had been firing all of its events, we could do undo properly, we could do replication properly, and so it's, and it's a good idea anyway for extension.
Like I know in .NET they have that you can wire up the properties so that when they change, it fires an event, and then you can take those instances of that object, you can put them in an observable collection, so that you can listen on that event, and so when the collection changes, you can get the object that changed, you can get the property on that object that changed.
Yeah, so one of the very nice things about C# is that properties are really built into the language. You just say, I have a property P of type T, and basically you've got a get method and a set method that comes with it. And I didn't know that they also fired events.
You have to like implement the interface and stuff, but there's some helper like aspect-oriented programming things that'll weave that all in.
So that's there in Java also. I'll show you that. Okay. So what you're going to do instead is broadcast not the method calls as they are executed, but the notifications. Okay. So we're going to have set P. Set P, so we're going to have an object that replicates and replicates back. So we have that infrastructure. Okay, you're getting to now sync. Okay, so we're not going to call it rebind, we're going to call this replicate, because that's what sync calls it. Okay, and now when you invoke set P, it's going to fire an event, and that event is captured by some software program that is part of the infrastructure, and that is going to be local or remote.
Well, it needs to be local first to catch the event, and then you can forward off to remote at the server.
You could have the guy be firing events on a proxy.
Right.
But, why make that object be a remote object? Okay? For instance, property change event, which is something that is a standard thing in Beam, is not a remote. Okay? So why not go and have some client program code, which takes the place of the proxy. Okay? That goes and gets that event, and what's it going to do? It can't access this directly because our object is not a remote object. Okay? And because it's not a remote object, it will send it to some sync server that is a remote object.
Fire the event.
It'll turn on the local copy and then broadcast.
Very good. Okay? It changes its local copy, sends it back to some remote object in sync client, which calls sync. Okay? This is what's happening in sync. And it's easy to explain, but when code starts getting executed at the server end and the local end, it all becomes interesting. Especially when your Halloween simulation doesn't exist at the server end, and you're trying to do something here, it will throw a null pointer exception. So you have to go and put checks in saying, if the Halloween simulation, if the display is not there, don't do anything. Okay, so that's the kind of issues that I was having with this weekend with the particular project. But that's what's happening, that the code is being executed here too. Our setter methods are not just setting variables, they're doing actions also. And they could be doing actions on transient variables, and we don't want the transient state to be created here, but we want the transient state to be recreated here. So this becomes an interesting problem.
Shouldn't the sync server be sending something back to you also?
You wouldn't need to unless you were waiting
For
We
a,
were blocking until you got confirmation that everybody was in lockstep.
and we sync servers expecting write methods to be void.
Because unless you get an error from TCP or something like that, you know the message got out. And that was received by the server.
And if there was, those errors will be reported by sync client and not by your local object. So that's,
Okay, so you're going to revert in that case.
We are going to just do whatever happens.
Yeah, so are there transactional semantics here, or is this a best effort?
Okay, so there is transaction. John Munson did put transactions in there, but I'm just not talking about them. Okay, and when we go to the end of the course, I might actually cover transactions properly. Okay, but for now we're just saying we're going to execute the set P, and set P is going to be executed locally, and if it gets to the server, then it's there for everybody else to see. Okay, but if a failure occurs, and a failure is not supposed to occur, because it's supposed to be always connected, and we can easily undo. That's not an issue. Okay, at the local end. But is that what you want? It's not even clear that's what you want. Okay, so fault tolerance and things like that is something that we can just not get into at this point. I mean, that's something. Those are all things that you can plug in on top. Okay. So you guys get the flow. Set P is being executed everywhere. That's very, very important. Okay, and you guys can even go and trace this. You can put a little debug point to see this really happens. And just to tell you that this adding these property notifications is not such a bad idea. In fact, the whole notion of model view controller, which is implemented in this object editor tool that you guys haven't used directly but have been using indirectly in this Bose project, is based on that. And model view controller is based on the idea of a model. An object is a model when its methods can be divided into read methods and write methods. The model view controller does not decree what are read methods and what are write methods. It just says there are some read methods, there are some write methods. It is the bean patterns that go and tell you, here's a formula for determining what the read and write methods are. Okay? But the fact that there are read methods and write methods are there in model view controller. And the controller is the one that does what? You guys know from what some of you who might have seen model view controller?
iPhone programming is all it is. iOS programming is all it is.
Yeah, and
It seems like the most nebulous part of the whole thing.
So
the controller.
A controller only talks to the view, and the model and the view are tied to the controller. The controller can be tied to it.
yeah, these guys, Smalltalk did things right, and Apple just screwed it up. Everywhere, when you saw I've seen the Mac come with the one button, and it just went to. So that is not MVC. That is Apple's. That's like cricket becoming baseball, and squash becoming racquetball. Things getting watered down.
The controller, does it listen for events from the view?
No.
And it's-
Okay, so let me tell you what the Smalltalk MVC is, okay, which we can defend. The web MVC is something you can defend only in the web model situation. And I think the Apple guys probably got it right because they basically copied from Xerox. But maybe, they're now young enough that they've forgotten what they copied. The view controller is the one that processes input. Okay? And it takes user input and calls write methods in the model in response to that. So if I go and say, enter command set, enter command a click, it converts the click into open document or some method in here. Okay? So it calls write methods here. The view is the one that goes and displays the object. Okay, so this is distinguishing between input, output, and semantics. The model is the one that keeps the semantics, the state. The controller is the one that keeps track of the input, and it goes and takes input and calls write methods. The model goes and broadcasts events to all its views, which are observers. The views in response take the notifications, plus they can call back read methods and display the state. It's so easy to explain this. I don't know what the justification is for the controller to have linked to the view. The whole idea in MVC was for the controller not to know about the view. Why?
So how does it convert inputs if it doesn't know anything about the view?
It's got things built into it. Give me an example. If you've got a text box, okay? And let's say you've got, sorry, I thought I have a UI somewhere here. Let's say you've got a text box. I was going to show you that. So let's just defer that question till I show you this screenshot.
Okay.
But it does. Somehow it knows that these events translate into this method. Okay? And the view says, here's a state I want to display it. Okay? Now, why would the controller not want to know about the view?
It doesn't care how it's displayed. It's more interested in writing to that object.
And how many views could you have?
Numerous.
You could have a textual view, a graphical view, a 3D view, a 2D view, a single D view, anything.
So how does the controller communicate?
It doesn't. It goes and invokes methods in the model.
The model informs the view if you change it.
All the views register with the model and say, we are views. We are observers of you. And the model says, I don't know what you are, whether you are a text view, a single view, a 3D view, or what you are. You're just an observer. That means whenever I change, I will call the update method on you. That's what I'll do. I don't know what you do with that update method. And every view will go and update things properly. That is the motivation for MVC.
There is an update method in every view.
Yes.
And whenever the view gets an input from the user.
View does not get an input from the user. The controller goes and calls write methods. The view can be written totally
Where he's getting confused is that the view contains your input, but what happens is the inputs link up to your controller.
Yes.
So the controller then does.
The controller and view can be coordinated in the following way. They can both be referring to the same text widget, for instance. Okay?
Exactly.
That is an internal thing, that they can both have links to the same text widget, which is possible in some cases. Otherwise, you can have a separate control panel, and when I go and do this, object system. So, and we tried many options. We said, okay, let's just keep all the instance variables consistent. And that was not right because we couldn't diverge. We couldn't figure out when the synchronization should start. And then we had to change the compiler. And if we do have to do all of these things, then the performance just stinks after that anyway. So, we saw lose situation. We said, okay, let's go and broadcast all the methods. Each method may be like a transaction. And then the question becomes, if you're going to broadcast all methods, what have we gained? We are by definition worse than a distributed system. And what you don't want to do is broadcast read methods. Okay, so then maybe we have to somehow classify into read and write methods. And then the question is, do we really want to put proxies to trap them, or maybe we can rely on notifications? And proxies is extra overhead. Notifications, well, people should notify anyway. Okay, that was the kind of argument. So if they're going to notify anyway, we'll trap the notifications, and you guys have benefited from that, right? And I put that thing in actually that because Bose code broadcasts notifications, you can trap when a command is entered, and then you can go and distribute it. Okay, so notifications in general are a good idea, and they're a good idea. The whole idea was invented, I believe, in the context of Smalltalk and model view controller as defined by Smalltalk, not by the web, not by Apple, though I suspect Apple is going to be a lot like Smalltalk. So what did that mean? And then we said, well, model view controller went in, just said there are read methods and there are write methods, and it was a philosophy. It was not a tool. If you're going to build a tool, then we have to really figure out what the write methods are, what the read methods are. Some tool has to figure them out, so we'll use some conventions. And we'll use the conventions that we've all been using implicitly, and they're the conventions invented in the context of Bean. And Bean, in the case of Bean, these conventions were conventions, whereas in C#, they're built into the language now. Okay, the notion of properties, and you have a set X, set property, get property, and so on. Okay, so that's where we were. And what we were going to do is we're going to assume we're going to build a replicated system on top of serializable system that supports serializable objects. And we have to first place the objects, replicas, on the various computers. And then we have to go and get them synchronized. That's two issues. First issue is relatively easy. We just serialize it, and then now it becomes interesting, and we assume that we've got this write method with a particular signature that we can, and we can find what the method is, and we'll have it send notifications that also follow some kind of format that is application independent, and the sync client will go and listen to its events, and it will go and send them to the sync server, which will go and call the set method in the server object, Okay, so these methods are being executed. Again, this is kind of dangerous stuff. This is not just writing, a database writing. Somebody is executing a method you wrote, okay, which can do a lot of things besides change the storage value. Okay? And then it goes and sent to the sync client, which goes and calls set p. Okay, so sync client has to know which method to call. It has to know how to listen to the method. The set p's don't have to be remotely invocable at all. Okay, all the RMI, all the remote stuff is in the sync client, and this is just has to be a serializable object. Okay, so that's where we were. And I also told you that, look, the notion of announcing events is good in its own right. It's good for building replicated systems. It's also good in its own right, and it was invented actually in the context of Smalltalk's model view controller. And to just give you an idea why there might be some confusion about this, this was in Smalltalk's book. Sorry, this was in Smalltalk code, and Smalltalk was supposed to come up with a book that described it, and they never did, or they did it very late, much after they did it. And there was a guy called Ralph Johnson, who was at Urbana-Champaign, and I was at Purdue at that time. And he actually was digging through Smalltalk code to figure out, how do these guys really use objects? And how do they really program? They didn't quite invent OO languages, but they invented inheritance. And he wanted to just see how they're being used. And he was in Urbana-Champaign, I was in Purdue, we were all lost in the Midwest together. So he came and visited me, and he told me about it. And this is how I know about it, and that's why I've been preaching a lot about it. And then finally, he wrote a book along with a bunch of other people. And do you guys know what that book is? Ralph Johnson, Gang of Four. Okay, so this is the guy who was author of that. And personally, I think this is the guy who's influenced software engineering probably the most in the last 30 years. And he did not get tenure at Urbana-Champaign. Okay, but he's still there. He's he's consulting there. He loves the place. Midwest has its benefits.
He invented Singleton and didn't get tenure?
He's one of the smartest guys I know. Okay, and he did not get tenure because he didn't have the required number of papers. And Dave Patterson, who got tenure at Berkeley for something in architecture. What's the most important thing that's happened in architecture that you hear a lot about your generation? Risk architectures. Okay, and he had only 3 papers, and he got tenure because Berkeley knew what it was doing. Whereas this guy, he's just a few years older than him, and didn't get tenure. So anyway, it always makes me angry when I think about that. Okay, but so model view controller is something that wasn't very publicized, and that's why people get really confused about it. But there is a paper on it. Okay, and if you were ever interested, I can send you the reference. Okay, so the idea is that the user interface, the input is in one object, the output is in another object. Okay, the input object can create something on the screen. There's nothing to prevent it from doing so. It's just that the view object is the one that visualizes the state in the model. Okay, so the model is just a keeper of state, and it has read methods to read the state, write methods to write the state, and it also has methods to register listeners. Okay, and so as a result, the view is just a listener. So you can think of this MVC being an observer pattern being a subset of the MVC pattern. Okay? And so that was where it came from. And here is some real code, which is what we ended, to show you how an observer could be written in a standard way. Okay? And also we want that observer to be a model that we can replicate. So here's sort of, we've made this serializable because we want to copy the state. We want to be able to notify events. Here's the setter and getters. Here's the notification. And a setter method can notify about all properties and not just the variable that is changing. Okay, so there can be multiple notifications fired as a result of a setter. Okay, so this is saying, look, my ticket price has changed and my total field has changed. Okay, total, and total is not really kept anyway. It's just a logical value. Yeah.
Yeah. So since it's a logical value, can you infer?
Can who infer? If I wrote a view.
Receives your message.
So that means if I'm a custom view, I have to know enough about the semantics of your application to know that, okay?
There are wars fought over this stuff. It was like, if you, in like just a business object, if the city changes on a person's work address, so you fire the city event, do you fire address change? And do you fire person change? Like how, like do you, because then you end up spawning like all of this communication out. But then on the other hand, it's like, you never know how the UI is going to be like set up. Is that all going to be on one screen? Is it going to be different screens? And so it's like, you know, just a big deal.
And the main point is that if I had a custom tool, but if I want a generic view and control, then, I wouldn't know. So I would know that I have to go and call
Right. So the goal is to decouple your UI from your object.
if possible. And the thing is that the nice thing here is that, and let's talk about distributed. I have gone and sent this message, and I'm not just saying to the original Smalltalk model view controller, they had two kinds of update methods. So one was, I have updated. You figure out how I've changed. And so the object, the view will just call maybe all the read methods, or the view could know about the specifics and go and call the specific. But the thing is that if I have changed in the USA and the view is in China, okay, I first told it I changed, then it went and called methods in me to go and to read my whole state, and we just told it what changed. It's like saying, hey, my website changed. You go figure out what changed. Okay, do diffs. Okay, and so if that is the case, if I'm sending the values along, then the nice thing is that I've sent both values that are needed. Even if the view knows about this, it doesn't have to go and make another call to find out what the total value is. It just got both values and it updates. Okay? But very few people in the world have created a distributed property change listener. In fact, the way property change listener is right now, it can't be just used in distributed sense because it does not implement the remote interface. Okay? So I did actually create a remote version of it also. And that's probably in that object editor library that I keep talking about. Oh, by the way, for your next project, please use the new object editor library also. And because it just is needed for various things that I added. Okay. I forget what, but somehow it's needed. Okay. Oh yeah, my sync server has been. Sorry. I had to change sync also, so I'm getting confused. But there's some reason it has to be used. Okay. Now I have my init serialized object method also, and this is going to initialize my state. And you guys get the basic idea of firing this thing. This is the thing, and Java provides you with actually a class that lets you go in, which will go and store the actual listeners. You don't have to worry about what's storing it in a vector, array, list, whatever. It keeps that. So you just go and say property change add listener, add property change listener. It keeps it. And this is a transient variable. So because it's transient, I have to go and initialize this in my init serialized object. Okay. And then it should work. Okay. So the listeners may be the replicated system that we're talking about, sync client, maybe the UI, or it could be other components. I don't know what I mean by that should not be serialized. Oh, because it's transient. Oh, I'm trying to explain why this thing is a transient variable. This is a transient variable because the listeners can be all of these things that can't be serialized. Okay, so I've come to this from a very practical point of view, saying, I want to keep the replicas consistent. If I'm going to keep the replicas consistent, I need to get some events from one replica and invoke methods in the other one. So I need that to be an observer. And we went into the properties because I need to know standard methods. But can we explain exactly in some theoretical way what the replication semantics are? I mean, sure, the replicated system is listening to, is trapping events and calling methods. We see that. But is there some system that should be used by both the replication system and the programmer together to ensure some kind of semantics? And what are the semantics that we're going to have? So what is it that is being replicated? We're talking of some state being replicated, perhaps, right? So what state is being replicated? And to answer that question is a little easier when we were going and talking about changing variables. Okay? That just said that, look, whenever I change the assignment here, I'll change the assignment there too. And let's forget about race conditions and all the concurrent actions. As long as they don't interfere, each object will have the same state in its variables. I mean, that's a very clear explanation of what happened. It may not be what we want. From a theoretical point of view, it's very well defined. There's no mysteries there. And, there's going to be some mystery with probably what we did. But let's try to demystify it as much as possible. So, and what we're doing is, like I said here, we are just keeping all the variables in the structure consistent. And so we can think of there being a hierarchical structure, a physical structure, a tree, or maybe even a graph. And that graph has got the same, is isomorphic, it's equal to the graph there. Okay? So the question is, when we go to this brave new world of ours, okay, what is the state we are trying to keep consistent? Or what is it what we're trying to do? I mean, yes, we've got to how to do it, but what is it?
So the initiation of an event should be disconnected from the visualization of the event. You should see the same thing happening wherever you are.
So what is the same thing? So somehow the semantics of the object should be same, right? And it was very easy to argue that the semantics of, physical replication were, this object is equal to this object, as long as equal works correctly at all times. Is it all in the eye of the beholder that, this is what that might be the thing, that, there's just something. It's all application specific, perhaps. And somehow this event triggering this method in this replica is somehow what we want.
You could probably get kind of formal with it if you say something like, whenever a get method is called, like say you have the same wall clock. If get is called on machine A and machine B at the same time, they should both return the same value. And then you could say something like, otherwise the object is kind of a black box. Like they may be inconsistent, but when you do that read, if you do the read out the same third-party wall clock time, you should get the same value. And then you can kind of leave yourself room there to maybe do some shuffling behind the scenes.
No. Why? This sounds good to me.
Yeah, well, I mean...
Rather than reading the variables, I'm calling the get methods.
Yeah.
So rather than keeping the physical structure consistent, I'm keeping the...
logical structure.
And that logical is not something that we're just going to invent out of thin air and say whatever is logical is application specific. Since we are dealing with standard patterns and so forth, your get really meant that somehow there are properties. Okay, that's what you really meant, that get P here should return the same as the get P there, and get Q here should return the same as get Q there.
Yeah.
Which means when I read property P, the same value should be returned in all. Right? And so we can think about a logical structure, which is something I even introduced in my 401 class. Okay, that we can take an object and try to figure out what its logical structure is, and we can use some standard conventions for that. And I have three components in my logical structure. My physical structure just had two variables: ticket price and number of attendees. My logical structure has ticket price, number of attendees, and total. This happens to be an editable property. This is like a non-final variable, and this is like a not quite final, but it's just a read-only property. Okay, it's something you can't change from outside the object. Okay, directly. And logical structure is defined by public members. Okay, so if you have public variables, they are part of your logical structure also. You shouldn't have public instance variables, but just in case you do, they're part of your logical structure. Okay, and each component of an object is a value stored in a logical type-dependent component. Okay, so and this type, we'll talk of beans, so they have one kind of types, and then we'll talk of other objects also. So I guess that's what I mean by type dependent. And here's the deal. Sync is going to look at your logical structure. It's going to divide the logical structure into editable properties and non-editable properties. It's going to keep your editable properties in sync. It can't call the set method for the read-only property. So for all of this to work properly, your set methods must correctly set the read-only properties. Okay? And it will keep the editable properties consistent. That's basically the guarantee you're getting. And that is why when it receives an event for property P, it calls a set P at the other end. Okay? Assuming this is true. And for all of this to work correctly, you, a programmer, should make sure that if you do a set P to some value V, and then you do get P, immediately afterwards, you should return the same value back. Okay? That's kind of being assumed here. You may go and change some other state also, but at least that should happen. And what sync will do is it will serialize the object at the other end. Okay? And it will send all the non-transient values there. And if there are some transient values that happen to be dependent on the non-transient ones, then it is the job of init serialized object to go and set those values. Right? If there are some transient values that are stored, but not properties. Okay? They may be stored, but they may still get read-only properties. So and during synchronization time, it will just send the notifications from set, and it will not do it. So in fact, sync will never call the get methods ever. Does that make sense?
So it just takes the independent, non-transient fields and communicates those.
No, it doesn't know what's transient and non-transient when you're firing events. Okay, it's funny. It goes and copies the physical structure because it uses serialization.
Right.
But it keeps the logical structure consistent. Okay? And that makes sense because if your physical structure is the same, your logical structure will also be the same, right? So as long as they're both same, that's fine. As if they're different, okay, then we can't use Java serialization. We need to use some other serialization. And guess what? That's a serialization that you guys will implement 2 projects from now. Okay? So sync would work better with that serialization, where you will be actually keeping the logical. That's why I want to get into logic a little bit more in depth. You'll be keeping the logical properties consistent and not the physical state consistent. Okay? This is just so that you could do something different from sync, from RMI, and yet understand what serialization really means. Yeah.
Methods are considered atomic as well, right?
Yeah. I mean, should they be synchronized? Should they not be synchronized?
I mean, what happens if I'm in the middle of something and you change my values?
Yeah. So the question is, does sync itself execute the update in a synchronized method through which everybody else goes, or does it require you to have it synchronized? The trouble is, I can say, please make all the methods synchronized. But the trouble is, we're all very mortal. And what's the biggest danger that can occur when we make methods serialized? Have you guys ever run into?
Current write exception?
No, it's much worse than that. Nothing will happen in your program. Deadlock. You set a breakpoint and you're saying, step in. It's not stepping in. It's not telling you also that I'm not stepping in because it's synchronized. I wish it did. And you're saying, oh, stupid Eclipse, it's just not working. Let me reboot, or let me reboot the computer. It's just not going in. Okay. So I'm not going to say. I'm going to say we're all mortal, and it's better to have in some applications an application that might have these race conditions, but at least that works, than one that locks. So, but yes, for instance, the objects that I create, like I've created a vector object that fires events. All the methods are synchronized. Okay, and that's exactly why, because I don't want 2 people to be changing the object. So the object can just make sure that it does so. Okay. And that's the same requirement from your objects, even in your the assignments you've done so far, right? That there are these multiple people changing the object, and you don't want the action to interleave right there. Okay. And just to let you know, this logical structure idea is used again and again in this class. A, to have sync file its events. B, for you guys to do your serialization. And C, you saw the UI that was built, that Bo had, and it was all done through a tool called Object Editor. That is the OE all 17 library that you guys used. And what does it do? It looks at the logical structure of the object and creates a GUI based on the logical structure. Okay, and it's a really useful tool, I believe. I built it around the same time Sync was being built. I had about 12 grad students at that time, RAs, and they were all building GUIs for each of their demonstrations. And I just said, this is too much waste of time. There's a mechanical process here, and my thesis had to do with some of that stuff. So I made one of those students go and actually write Object Editor, just for our purpose. And Sync still had its own UI. And then, and indeed my research group started using that Object Editor to create the UIs. And then one day I started teaching CS1. And I said, if I don't like writing GUIs, these poor CS1 students should definitely not write GUIs. And that's when I had a eureka moment, and I said, okay, why not just have the GUI generated for them, and they just program the objects, and they get nice projects, assignments. And that's the kind of stuff that, essentially Bo did. He was in CS2. But anyway, so there's this tool that I use for demos all the time, and that I'm going to use for an example. So for instance, the object that I just showed you, the concert expense, this is the UI that it generates. Okay? I don't have to write a GUI for it. I can show you, I can go and do my race condition demos, easily because I've got a UI to do it. Okay?
I was going to say, have you ever heard of the naked objects paradigm? It's sort of like that. Like there's this whole kind of class of software engineers where they're like, the only thing you should ever write are your domain objects. And just like you have object relational mappers that do all the boilerplate code you're talking to a database, they said that your GUI is pretty much all boilerplate stuff. So it's like, they don't look pretty, but it's like the Scottish pension system. This company got a contract to do it, so it's like a huge thing. And they used this paradigm, and they just said, all right, we're just writing the domain objects, and we have this tool that will look at the domain objects, and it will create person, address, everything. And it's basically just like that. And they say, like, you should only ever be concerned with those central objects.
So, yeah, right, exactly. I have actually a Toplis paper, which is automatic generation of user interfaces. And that was the main point of that paper was that, programming, I was into programming languages and operating systems. And my advisor said, hey, we are inventing a new operating system, which I was working on. Let's invent a new kind of UI for it, whatever that means. Okay? And I was interested in programming languages, and I said one of the things that really stink in programming languages is I/O primitives. Everything else is easy, but you have to do input-output of just simple types. You can't do input-output of complex types, and the GUI is all wrong. It's very stream-oriented. So I went and got this graphical UI idea, and then changed the programming language to support I/O of this kind. So you didn't do read object and write object. You did make object editable, and then you could edit the output to get input. That was the basic idea there. And then you have to go and display the output properly. And so I'm kind of one of the pioneers in this thing. But this is a whole field here, and this field gets a lot of flack. Okay, so people think that that's not the way to go, even though this is this is music to my ears. And there's a bunch of Europeans who are part of this community, but this field has basically died away. Okay, except that the mobile computing guys have suddenly found a use for this, and it's suddenly surfaced again. But I still think it's good, and the contribution that I have maybe over what these guys do is that I'm not assuming anything about the domain of the objects. Okay, which a lot of people I'm saying, give me any programming language type and I'll do something for it. And that's a much more ambitious goal. And you have to have the right extensibility tools also. Okay, so I'm digressing a little bit, but I'm just saying that for me to make some assumptions about the program, I need its logical structure, and logical structure gets thrown in many places. Okay? But the reason why it's dying out is that people sometimes sell new products by changing the GUI. And people want creativity in designing the GUI. It's only people who are like command line oriented, like some of us are, who say, what's in a GUI? I mean, you just press buttons, right? Who cares if it's red or blue or 3D or whatever? But a lot of people, I mean, why does iPhone sell so much? I never understand the wars over cell phones. I mean, they're all press, type. I mean, it's all GUI. It's not command line. So they're all the same. But people care about these changes, so people want to keep inventing in the UI domain. So yes, if you want to build the Scottish pension system, I don't have much money, you'll do that. But if you're a Facebook person and you're trying to say, come to my social networking site versus that social networking site, let me have a prettier GUI. Let me change the Windows GUI every year so that you feel you're getting something new. Let the car models change from flat to rounded edges to flat so that people feel they're getting something new. So, having said all this stuff, I understand, that people are, it's just the programmers.
I thought it was pretty interesting just because I don't like writing GUIs either.
Yeah. Yeah, but see, the way I said it, posed the question was, I'm doing demo GUIs, right? I'm doing student GUIs. So you cannot argue against that. Okay? And if you're ever interested in this, I actually have a tool that's extendable, and I'll argue that you can build any user interface using it that you can build using AWT, and you'll build it with much less code. Okay? That argument I'll give. Except you have to learn my API to do so, and there's no Stack Overflow comments on that, so finding help for that is going to be challenging. So there's all that stuff. Anyway. Okay, so we understand structure, and let's go and understand logical structure even better. We understand what beans are, that they're just records. Okay? And if you think of programming language like C, there are records, and there are sequences, and there are tables. These are the three fundamental structure types there are. Okay, so you need some way of actually capturing some kind of sequence. So I've got now a sequence here, an int history implements, sorry, this should be capital I don't know how this happened. I was doing some global substitution, I think. And I've got an array, I've got a max size, I've got an array, I've got the number of elements in the array, and I've got get method and add method to get and add methods. Okay, so this is, I'm calling it a history because it's a list from which we never delete elements. Okay, so what is its logical structure? I mean, how would you describe its logical structure? We know for a bean, the logical structure consists of the properties. The logical structure here is something that you can get by. Get how? If I'm sync, if I'm the GUI generator, what rules should I follow or what should I do to get the elements of this particular object? We agree that this is not an atomic object. It can be broken into elements, components. And I can get its components by? What are the read methods? Get and size, basically. And the write method is my? So again, different write methods, different read methods, but we have write and read methods. Okay? So its logical structure, physical structure, consists of an array and a size field. Okay, so if I do ints add 3, I get the size field is 1. I've got one element in it, and the contents is an array with 2 elements in it. Because this is my physical structure. And my logical structure would be what? If I was to draw a diagram, what kind of diagram would it be?
About how you draw it.
Yeah, so let's decide how to draw it. Basically, parent, child. So how many children do I have in this logical structure? In the physical structure, I have 2 children, the size field and the array, and it's got other. My logical structure is what? Some structure, some collection. Let's not call it an array.
A collection of things.
And it's just.
It has one thing, and that thing's the number 3.
That's it. That's the external view. Right? In fact, your array is also a logical structure that is, that's how I basically, but it's also physical. And so we can define bean-like patterns for lists and tables. What they are, it doesn't matter. The question is that if we define these patterns, nobody's going to complain because they're just standard. Why would you complain about it? Well, one can say we want creativity in the programming interfaces, but I think programming guys have enough interesting things going on in their life that they don't want creativity in just the method names. That I'll go and use this kind of name. And so array list, size, get, add. Okay. When you guys see discontinuity in the recordings, you know who to blame now.
So, you said the logical structure is determined by the public read method.
No. Public members. It could be public variables, it could be get methods, it could be set methods. If we lose a recording here, guys, he's taking notes. Just remember.
Yeah.
He's going to post them.
Not great notes.
Well, but still, you're doing a good job there.
I only have meaning to be.
Physical structure. And physical structure again is going to be
it's got size, content,
field,
array list. And what should I put under array list?
And my logical structure is the same. So again, like I said, we can serialize object of one kind into object of the other kind because we're just looking at the read methods and write methods. Okay. To determine the logical structure, I think read methods is enough, but to keep them consistent, you need also the write methods. Okay, so what kind of pattern can we develop, to go and figure out that, okay, both of these things happen to be the same? Well, we can go and decree this particular interface, okay? But then, what about, should the interface have an insert element or should it not? Should it have a delete element or not? So we don't want to decree a particular interface, but we go in, we don't want to call it something also because you may want to call it something. So we can just assume certain rules, and I'm just giving you the rules here, which again, there's nothing sacrosanct here. They're just based on vectors here. So you say, look, you've got to have a get method that returns some element of some type. So this is a collection of elements of type T. Okay? If you have a method called element add, perhaps, okay, that returns a value of type T and takes an element of type int2. And this is writable as long as you have some method set, can return any value, which takes as type the same T and an index. Okay? And then I can even define something for the add. Okay, that add also will take an element of type T. So I can define these rules just as I define the rules for get and set. Yeah.
Why is it any translate to set?
Any meaning, it could be void, it could return a value. See, some people go and return back the value you overwrote. So you say, okay, and you can do the same thing for set or set element thing also, you can imagine. Okay? So I'm just assuming that, you know, when I as sync or as object editor go and do an analysis of your object, I'm going to just disregard what you return. I won't use it, but if you have a type being returned, I won't go and say it's not a separate. Okay? So I can go and take the canonical operations that are on lists, insert, delete, set, and define such signatures for it. Okay? So, you know, how you do it, again, I don't want to get into it. The point is you can do it, and if you do it, life gets easier from a replicative system point of view, from a serialization point of view, and so forth. Okay? So these are the read methods. Unconstrained type, void or T in practice. And this is your write method. And this convention is based on vectors. And, you know, when this system was designed, you can see how old the system was. Array lists were not invented. Array lists got added up later. I know in object editor I do support array lists. Maybe in sync I do, I don't, I forget. Yeah, that's the change I made. I made a change to object editor to accommodate the add method, I think, from sync. There's some kind of change like that. Okay, so these are my read methods now. This is my write method. And, you know, that's just another convention. Okay, now here's the interesting thing. These patterns, these are being followed by vector and array list. Okay, and I can go and I read the values. But I cannot keep these objects consistent because arrays and vectors do not fire any events. In fact, there is no fire event standard for lists. So we'll have to invent one. Okay? I mean, it's bad to have to invent standards. In fact, you know, Ralph Johnson's claim was that he didn't want to go and find new patterns. He wanted to invent new patterns. He wanted to find things people already do and catalog them. And that is sort of a stronger statement to make. Maybe you're not being as creative in terms of invention. You're being more a scientist than an engineer. But he wanted to be a scientist in that sense. Okay? So, you know, we will go and that's just there was a property change event, and the property change event consisted of what really? It consisted of the property name, the old value, and the new value. Right? And let's just spend a minute trying to figure out what my collection, I call it vector change event because to me, all collections were vectors at that time. And now I'm kind of stuck with it because I have a lot of software that sort of uses it, uses this name, some of which I can't refactor. What are the events that you would have here? You'd have an event for insert, add, delete, and so forth, right? Now, and I would have the value that's inserted, right? Now, in the property change case, I gave you always the old value. Okay, I said, here was my old value, here's my new value. And the nice thing is that, why do they send the old value across?
Maybe some comparison.
Some comparison. Maybe if the two values are the same, you don't do anything. Maybe you do. Okay, that's actually a big question in the UI that you guys are using. If you say move 5, and then you say move 5 again, it does it a second time, right?
No.
You have to do move 5, move 5, 6, move 5, 5, move 5, 6.
Okay, that's because I changed my mind. So when you use the new object editor, I haven't used OEAll 17, you know, for a long time. You say move 5 and you say move 5 again, it will go. So that's always the question. You know, maybe when the values are the same, you don't do anything. That was an optimization. Maybe you do something because it's the same command being executed. Okay, that's why the model has announced it. The view can decide what to do with it. Okay, so what might you need as an old value thing? The whole array, the whole collection, the element at that position, who knows? Who knows? One thing you need to know is whether you got back the element that you sent. Okay? And one way to figure out whether you got the element bounced back to you is to just compare what you got with what your current state. Okay? And you say, okay, my property is already 5. I got back a 5 from somebody somewhere. Maybe it's my own element having got bounced back because somebody did not do the bookkeeping right. So I won't go and call my set method again to go and start the cycle all over again. Okay, so that's one reason why you might go and look at the value. And that's what sync does actually. Even though object editor has changed, sync, if you go and change the same value multiple times, it says, I'm not going to send this across the second time. Same logical state. Now you start getting into trouble with the logical state semantics. Okay, and maybe you should not be modeling that as a property, which is the kind of lesson we will see from the next assignment. That we don't want to model our input string as a string property from replication point of view. We want to keep some kind of history. Okay? We want to keep some kind of collection around, which is why I went into collections. Okay. But I do send the size field also, because then you can say that, wait a minute, I inserted an element and my size became this. Now somebody's sending me an insert element event, and it says that the new size is the same as my current size. That must mean that I probably got it bounced back. Okay, so just this kind of information. For that reason, I add that stuff. So I have a vector listener with update vector, add vector listener, and the end. You know, people sometimes don't use enums, so this should really be an enum, but it's not. Okay, so I have these codes, so this is just the event type, the source, just as in property change, who sent the event, what the type of the event is. In this case, there can be many kinds of events. Position at which the event occurred, whether it's a remove or a delete. The old value, whatever that means. If you're doing a set, it's the last value there. If you're doing a insert, maybe it's the value before that, or maybe it's null. Okay, the new value and the new size. Okay, that I also set so that you can do some kind of bookkeeping. Okay, so useful to detect bounce back. That's kind of the point I'm making. Okay, and here's something that's using it. Now I will go and say new vector change event, add component events. So I implemented size already. I want to send this event afterwards. So I go back to the size that was the old size. Sorry, I send the old size also. Okay? And I send the new size. And I send a null for the old element. Okay, so I forgot there was also a new old size field. Okay? I don't think you guys need to use this directly. Because you need to listen to events, but I'll just give you an object that announces events, and you'll be able to use it. And so you can just use something called a listenable vector, which is just a vector that is observable. Okay, and you can just use that in your project.
Another nice thing in .NET, they have observable collection.
They do?
Yeah.
And they do have events like this of some kind?
Yeah, it's like I was talking about last class. You can, as the elements are inserted into array, the collection will listen to the events on those elements. So if you change, like the city field of the address of a person that's in a list, the list will fire an event that says, hey, this item changed. It's for like the things in the list changing, not like the list grows or something because the backing array.
So what about the list changing itself? The elements, I don't understand what exactly. I mean, I kind of understand, but not quite. I mean, why isn't that object itself announcing? Why is supposing the list consists of a concert expense, and the concert expense consists of your three properties. Who's the firing event? The list or so if I change, do I fire the event or some ancestor of mine fires the event? Or both?
My understanding is that the list will listen for
Events from his children,
from its
descendants.
contents, yeah, and then it will fire a generic event, like
With the index in it.
yeah, and then I'm not sure.
Yeah, fine. They want the index. They want the listener to also, they want the observable to know which element changed.
Yeah, I'm trying to think back. This is a couple years now, but there is a way to get to the actual thing that changed.
Yeah, of course.
In the object.
Yeah.
In the list.
Okay. But again, this is a little different. This is saying the list is self-chaining, and I don't know why they don't have events for this kind of stuff. You know, and this is where people sort of invent, you know, if they were going to do that, why not do this too? I wouldn't have had to give a lecture on, you know, what the API I have invented is, which is nothing profound there. Anyway, you need to have an add vector listener method also to do this. Okay. Oh, I'm sorry. This is not the old size. This is just where I added the value. The index that changed. That was what it was. That's why I was wondering. I didn't think I had an old size. It just so happens to be the old size also because we're doing add. Okay? Okay. So basically, if you're doing physical, you're also doing logical. If you're keeping two physical structures consistent, you're also keeping the logical structures consistent, right? If you're keeping the logical structures consistent, you may not be keeping the physical structures consistent. Okay? And the approach used so far is kind of a hybrid, which may be somewhat confusing, that just because it was convenient, we are using Java's capability to copy the physical structure, but after that we are keeping the logical structure consistent. Okay? So basically, ultimately, these two objects have to have the same physical structure to replicate, but once they are replicated, just the logical part is being kept consistent. That's what's really happening. Okay, and this might cause some confusion. Okay, so what really happens now is, again, I'm sort of, this event flow thing, your whole program is going to be like these many lines of code, except that you've got to figure out what the event flow is, and so I'm really belaboring the event flow, and really I'm making sure you understand what's happening so that you know what to do. Okay? So your model is firing events, and it is being listened to by the sync client, and the sync client is basically just a name server where you go and register models. Plus, it's got these. Since it understands the logical structure of your object, it can offer other kind of functions that are structure-based, which we'll get into. Okay, and we have the models can be, have components that are properties. So this model can be a record with properties, a vector, a list of some kind with elements, a table of some kind that is also listenable. Okay, and the other thing is that the sync client is something that can buffer your changes. So that when you're disconnected, during the disconnection time, it just is buffering them. And buffering becomes an issue too. Because if I get two set methods, two set events, events that change the same property, should I store both events or just the latest event? The latest one. Okay, but again, in your application, if there are 5 commands being fired, you want all 5 to be stored. So again, what you don't want to replicate is the input string. You want to replicate something else, just because it is not defining the exact logic structure you want. Okay. And because of that, there is some way to go and say. Also, there's a way to go and this was added later. Sync was really meant to be sort of Dropbox for arbitrary Java objects. That was the goal at that time. Meant to be an asynchronous system. The idea was not that as I'm changing a file here, you see it changed. Okay? And it was really meant to go and allow you to have flexible merge semantics and so forth. And so we would synchronize only when you said synchronize. Okay? You don't do that in Dropbox. Dropbox does it periodically. But there are tools that say, like in version control, where you say synchronize now and it goes in. Then synchronizes. Okay? And then we added a routine that. But you can call synchronize in some process that goes on periodically synchronizing. In fact, I told you guys about this patent stuff that I was contacted about. That Samsung was being sued by Apple, and Samsung was claiming that Apple was claiming that Samsung has stolen something which actually is in sync. This has to do with this kind of synchronization. It's just such a small issue, you know. We guys spend all our time doing merge semantics, and I would tell the lawyer, yes, I can go and invoke synchronize in a daemon process. That was the whole point. That can I have a separate process doing this and in a separate thread? That was the whole thing. So it's, you know, some of these patents sometimes are pretty lightweight. Okay, so and we can say set real-time synchronize, which means every property event will go and fire synchronization, which means you will do the merging on every event. And we tried doing it on a local area network, and we tried dragging a mouse on one computer, and it just dragged smoothly at the other computer. So wow, we can use it in this mode. We didn't think we could. And since then, Sync has been used for many projects. In fact, projects that people have used for real work to build synchronous applications also. Okay, one student of David Stotts built a tool for allowing somebody who can't see well to collaborate with somebody who can't hear well, and they were building UML diagrams. And the UML diagrams were being kept in sync through Sync, using this real-time synchronization. And so it's okay. So there's a little button that you can even press on the user interface to make that happen. Okay. So the model sends notifications to Sync client, and the Sync client invokes write methods in the model. So the Sync client is both, I think this is what I say, Sync looks like a view and a controller to the model. Okay. And by the way, when I tell you the view and controller were separate objects, and you guys said no, but sometimes they both have to share the same GUI. And because they share the same GUI or the same frame, some people said it's not model view controller, it's just model view, and the view is both the object, it's the controller and the view. In fact, guy at Stanford, Mark Linton, who also didn't get tenure, unfortunately, he invented a system called interviews. Anybody heard of that ever? Okay, it was one of the nicest toolkits. In fact, just since I have 2 minutes, I can just digress a little bit. He's actually a graduate from Berkeley. He invented the idea way back. I was a grad student at Wisconsin that time, and I remember hearing this talk of storing your syntax tree in a database and writing queries to go and actually, so you want to figure out what's happening in your program, you just query this database using relational language, and he showed that the performance would be too bad. So he invented that, which was a very big deal idea, I think. Then went to Stanford, invented this particular interview system, and he said the view and controller should be not model view, but editor subject. Subject is the model, and editor is the view and controller together. Okay. So that's what this is behaving like. It does not call read methods. Okay. And 30 seconds. Oh, let's just start from here next time.